All right, everyone. So now we're gonna start like the second part of this room for the day, which, as you see, will be the Lua dev room. We had like a small mashup with the Gal guys in the middle, and then we're gonna be like full Lua till the rest of the day. For the first talk, we'll have Pablo Musa from Elastic, and he's going to present Elasticsearch Lua, building Lua applications on top of Elasticsearch.
Okay, so good afternoon, everyone. My name is Pablo. I've been a software engineer for almost 10 years, and my passions are distributed systems, data analytics, and of course, Lua. So I'm going to talk a little bit about how you can develop Lua applications and use Elasticsearch as a storage or as a base for it. So the first thing is what Elasticsearch is. Like, who knows Elasticsearch? Okay, who has used it or is using Elasticsearch? Okay, quite a few of you. So Elasticsearch is an open source, document-oriented, RESTful, full-text search engine, and with soft real-time analytics capabilities, as you can say. So basically, it's Apache 2. Documents are described as JSON, and when you write something to Elasticsearch, you're actually writing a JSON document that will be able to retrieve exactly as it is. It's RESTful, so everything is done over an API on HTTP requests. So that's the lingua franca of internet, and with JSON and HTTP requests, you can do almost everything. And almost all languages have some support to both. Regarding full-text search engine, you can do all of the things that you could imagine regarding search. So when you go into Wikipedia and you start writing into the search box, Elastic, what's running behind it is Elasticsearch. And you can implement autocomplete, highlighting, geo features, all within the search that you are doing for your website or for your application. And not only that, you can also use Kibana, which is another open source tool from Elastic, to build the dashboards. But the core engine that's running behind it, that's aggregating the data, is Elasticsearch itself. Okay, so it's very powerful. So it's very easy to just need to download, untar, and basically execute Elasticsearch. All you need to have in your machine is Java. And then, using HTTP requests, you can do many interesting and cool things. And I'm going to show a little bit about it. So Elasticsearch Lua was created in a Google of Summer project together with LabLua and Elastic, as I was in Elastic and I used to be at LabLua. And the main thing that I started thinking was, okay, we have Lua here and JSON here, and what are the differences? What do we need to do to make sure we write one way or we send it in the other way? And basically, for me, they are very similar as describing documents. So for now, we don't have any layer on the language itself to implement the search or the analytics. So basically what you do is, instead of writing the JSON, you write it in Lua, and we use CJSON to change it away. So we kept the DSL and all the things that you would write in JSON, you just write it in Lua and we do the change. So going to CRUD, basically you have an object or a document, the way you want to call it. You require the library, you instantiate a client, and then you send an index request, meaning you want to write into Elasticsearch. I'm getting an example of papers in a workshop or papers in some conference, something like that. And you have the index, which is the base data separation inside Elasticsearch. You define a type, an ID for your document, and here I'm defining the paper, here the object, and I'm sending it with a key name that we call body. To get, you just send the client get, again, the index, the type, and the ID. That's the real identifier of the document inside Elasticsearch. You can also do an update, so you send just the changes that you want to do. So I'm just updating the title over here. And of course, you can also delete. So very simple, very straightforward, no big deals here. Okay? So yeah, Elasticsearch, of course, you can and you should do search. And how do we do that? Very simple again. So index where you want to search, the type, and the query. So here I'm searching for requirements, just like that. Okay, there are many internal things that are happening and the abstractions that Elasticsearch tried to give to you, but this is a nice way of doing search and you get good results as well. So again, I can send a search, and instead of searching into requirements, just requirements which will go into all the fields of my documents that are actually indexed and search for this token, for this word, I can say, okay, I only want requirements in the title. So I'm binding the word requirements to the title field of my JSON document. Okay? And we can get much, much more complex. We can actually do a multi-match. So I'm matching the same query in multiple fields. And actually, I'm doing that in many different ways. I'm looking to keywords, title, and the abstract field. But in keywords, I'm giving a weight of 10. In title, I'm giving a weight of 5. And in abstract, I'm just giving a weight of 1. That's the default. And I'm also adding a filter over here, which says, OK, I'm actually just want the papers for the last 3 years. OK, so we have this nice syntax based on the Yoda library that you can say now minus 3y. All right? What you get back, it's a JSON response that we transform it into a Lua object internally that you can handle, which will contain the time it took for the request, if there was a timeout or not, the shards. This is an internal piece of that actually contains the data, so you can see if you got all the data that you have, and then you get the hits, which are the actual documents that you were getting back. All right? So we got only one document back, and the max score for those documents are 0.17 in this case. And then you get an array with all the hits, and for each position of your array, you actually get the object itself. So here is the object with the index, the type, and the ID, the score for this specific document, and then you get the source. And the source is exactly the same thing that you send to Elasticsearch. So the document, the JSON that you send to Elasticsearch is exactly what you get back. So you can play around with it. Okay, I could choose the fields that I want, but here I'm getting all of them. All right? Okay, but why using Elasticsearch? What is the motivation behind it? Why would you start using Elasticsearch and play around with it? So I used to work in this website at PUC in Brazil in the university, and this is basically a website with all the papers, all the publications for the engineering requirements workshop. All right? And it's a very simple website. You have like the main page with all the years over here that you can click and look, and a search box that's based on Google search. All right? So if you click in one of the years, you see a raw list of the papers with a few informations like the number of downloads for the PDF, the Scholar link, so you can look it into Scholar. And there is also another link that gets you into the most cited papers. So it orders, again, in a raw form, the papers based on the citation. So it's a website with 3 pages, really simple. It was designed with Apache, CGI Lua, MySQL, and the search was based on the Google search. And what I did was look into that and say, okay, looks old-fashioned to me. I want to experiment new things. I want to change. Let's move it into Sailor and Elasticsearch. So the CGI Lua versus Sailor part, I'll leave to Etienne, who probably knows more than me about it. But basically, I was very used to that, but there is no one maintaining CGI Lua anymore. And Sailor was this cool project with many of new things and a lot of new features and growing, and I decided why not to try. So I just changed it. Everything went really smooth, maybe a topic for another call. Regarding the database part or the data part, I had MySQL, and now I wanted to use Elasticsearch. But Elasticsearch is not a database, okay? You can use it to store data, but you don't have transactions, you don't have the ACID semantics. It was not built as a database. But do we really need a database, or we just need some place to put data and then retrieve data? Like, we update the website once a year with a few documents regarding the papers that were published, and that's it. I don't need a database for that. I don't need nothing fancy with transactions or anything. Okay? So this was cool to change. On the other side, MySQL is not a search engine, but do we really need a search engine? Some case you just don't want to put it on your website. Google search is fine. In my case, it was too ugly to actually write something here, redirect people to a Google page with the links, and even worse, the results that you get here, you cannot change it, you cannot do any modifications, you cannot say, okay, titles are more important, take downloads into consideration or take citations into consideration. It's just what Google gives you back. And I really wanted to change that. So with Elasticsearch, I could implement my own search result page, which you see is terribly looking, but I could change the relevancy. I could choose it. I could give more weight into title, abstract, downloads. I could implement autocomplete, highlighting, geo, anything I wanted for my application. And finally, everything would be in Lua. All right? So moving to Elasticsearch, how was it? So we got MySQL, and I needed to go into Elasticsearch. Not complicated. Load the Lua SQL code over here. So just install, use Lua Rocks, read from the database, do a select star, iterate over the conferences. For each conference, I will get all the papers for that conference, create what we call in Elasticsearch a bulk request. So instead of inserting one paper at a time, I got a bunch of papers together and send one request with 30, 50, you can choose the number. Very simple script, took me, don't know, 15, 20 minutes to do that ugly thing, and all the data is in Elasticsearch to play. When we change from a database, relational database, into Elasticsearch, which is not actually a database, we need to think about, okay, how are we going to model our data to play around with things? So we can denormalize data, we can use nested objects and parent and child, all of them more complex, but I chose parent and child just to keep exactly what I had. We can do one-to-any relationship here, and that's what I wanted. One conference, many papers. So how was the mappings, or the schema, we call it mappings. So the first thing is Elasticsearch has dynamic mapping. So you just need to send documents, and we will look at the document and figure out and update the mapping accordingly. But sometimes you want to tweak it. So I needed to tell Elasticsearch that papers had a parent, which were conferences. So I was creating a relationship here. I needed to say that ID was an integer and year was also an integer. Otherwise, as a string, I would get problems doing sorting. And I also needed to tell that paper session should not be analyzed. This is good when you want to do sorting as well, because if you analyze a string field, you get problems. I don't have time to get into that, but that's the simple configuration I had to do. I didn't have to tell about title or any other field. All of the other fields, if they are strings, they would be analyzed and available for search. Then minimal code changes, loading, almost the same. Instead of select star, I just needed to write a little bit different. I want to sort by ID. I want all of the documents. This is a number actually. It used to be a local variable, like 1000. Send the query, and here, again, it's just doing a get instead of select where. Just changing a little bit the way you write it. Very straightforward again. Of course, modify the search box from the Google into the search box. And now instead of this page, where actually I get back my own main root thing, and also here, I can only get a list of all the documents I had. So I'm searching for requisitos, which means requirements in Portuguese. I can even tell the user about the quality of the results, and I can do this page as I want. I'm not good with UIs, I just left it raw, but anyway, you could tweak it. How was the search? simple function, query, size, the index, the type. The query here is exactly this name. So that's what I'm passing here. I send a search, I get back results, I put it in the screen. Okay? Is it that simple to do the search? Yes, it is. You can do it much more complex if you want, but I just wanted to prove my point. Finally, Elasticsearch is not alone. So when you go into the Elastic family, you have a lot of things to play around. We have Kibana as one of the most interesting, and Bits. So I could actually install Bits and start collecting data from the computer, like top information, CPU, RAM, just dump it into Elasticsearch, and then build a nice dashboard like that. So I can see the papers over time, papers in English, Portuguese, and Spanish, the most keywords that appear in the documents, and any metrics that you want to put together. So the next steps, we need more use cases, more real applications. We need to improve tests in the library, actually update to the new versions of Elasticsearch, automate integration, and finally, when it's mature enough, make it an official client, and of course, do a Lua Rocks, a Rock spec. Yeah, thank you very much for listening. If you have any questions, I think we have 5 minutes.
Thank you, Pablo. We do have 5 minutes for questions. Does anyone have a question?
No questions. Shy people.
Yeah, no questions?
Such a shame.